Good evening, everybody. So what I'm going to talk to you about tonight is about Apex Unit 4 and the first section. It talks about things like dimensional analysis, which is a type of math that we use whenever we're working with the mole, and the mole is the second part. And then the third part has to deal with molarity. But we're going to concentrate in this video just about dimensional analysis and then also the mole. So let's start with dimensional analysis and what that actually looks like. So in the process for dimensional analysis, you have usually one number that's given to you. So let's say we're going to go ahead and convert. Like today I drove up to Wilmington. So let's say Wilmington is approximately 50 miles away from here. And we want to maybe convert that number into kilometers. How would we do that? Well, what you do is you set up a grid. And in that grid, in the top part, you always put what you're given. So the number that they gave us was 50 miles. And then you want to cancel it out with the same unit down in the denominator. And so we're going to put miles here. And you're probably like, well, what goes in the top space? Well, we need something called a conversion factor. Now, what a conversion factor does is it allows you to convert from one unit to another. So, for example, we can convert miles into kilometers. You could use the internet and you could find out, basically 1 mile would equal how many kilometers, or maybe you know some information already. Maybe you run races. If you run a race, 5 kilometers is 3.1 miles. So we could use that as our conversion factor. So if we take a look at this, what are we going to put in the denominator? Well, we're going to go ahead and put the mile. The mile is 3.1. And the reason why we're putting a mile here is because this unit has to cancel with what's down here. And what goes on top is the other side of the conversion factor. So since we've already used this side, the other side, which would be the top, would have to have that information. So that would be your 5 kilometers. And then if you do the math, these two things are in the numerator divided by the denominator, and then that would end up giving you your answer. So we can go ahead and do that on our calculator. So if we take 50, and since we're going across, we're going to multiply by 5, and then divide, because we're going down, this is in the denominator, by 3.1. That gives us 80.6 kilometers. So that's the distance 50 miles would be in kilometers. Now sometimes it's not simple like this. This is what we call a one-step problem. This is a one-step problem. Sometimes they can give you like a two-step problem. So let's maybe use some other conversion factors as well. So for example, we know that, and maybe you don't know, you'd have to look up online, but if you wanted to figure out how many feet are in a mile, it's 5,280 feet. So there's another conversion factor. Or another one would be like, okay, how many inches are in a foot? Well, there's 12 inches in 1 foot. So all these are units of what we call conversion factors that allow us to convert from one unit to another. It can be distance, could be volume, could be mass, could be pretty much anything. So let's start off with another problem, and let's say that maybe we're going to drive to Smyrna. And Smyrna from my house is not very far. It's probably like about 16 miles away, so we'll start there. And instead of converting it into kilometers, maybe we want to convert it into some other unit. Maybe we want to convert it into meters. So, well, we're going to need to know some information. So how many meters are in 1 kilometer? Well, there are 1,000 of those. So let's go ahead and use these pieces of information to help us with this problem. So we're going to go ahead and we're going to start with the 16 miles. Now remember what we did up above. We want to get rid of miles, so we want to bring it down. And now we need a conversion factor that will work us towards our goal. And our goal in this problem is we're starting with 16 miles. And we want to convert that into, what do we say? We want to convert it into how many meters away would that actually be? So do we have anything that we can work towards meters? Well, we can't go directly to meters yet, but we could go something close to that, which would be kilometers, right, or kilometers. So if we take a look, we've got up here 3.1 miles is 5 kilometers. So the 3.1 would go on the bottom again. Why? Because these two things have to divide out. Whatever this unit is, it's always going to appear down here in the denominator. And so we're going to utilize that part here. And then the other side of the equal sign is going to go up top. So that's going to end up being our 5 kilometers. Now we're not done yet. We have to convert this into meters. So we're going to extend this over one more time. And it's like starting over with a problem. Okay, we've already utilized this part. So we're going to bring Km down. We're not going to bring the number down. Remember, the numbers that we get here are going to be from our conversion factors that we're going to choose, that we're going to use to do these type of dimensional analysis problems. So we do have one that talks about kilometers and converting to what we want to, which is meters. So we can go ahead and use that. So in front of meter, we would use the 1,000. And in front of kilometers, we would use the 1. And again, the numbers should diagonally cross out. So here's how we started the problem, just as a review. We start with miles. We bring miles down. And then kilometers goes up top. So we're using this conversion factor to go from miles to kilometers. They want us to figure out meters. So we have to bring it down into a smaller number again. So we're done with this. Bring the km down. And we can go to meter up top because we do have a conversion factor that will allow us to do that. That 1,000 meters is equal to 1 kilometer. So we put the 1,000 meters up top, the 1 kilometer on the bottom, and then we go ahead and solve. Now this time, we're going to go ahead and multiply everything in the numerator, and then multiply everything in the denominator, and divide the two. And really, you can do it different ways because you've been taught in algebra that order of operations, that in the math in parentheses comes first, and then you do multiplication and division, and then you do subtraction and addition. So multiplication and division, we could just do it this way, and this is the way I do it because it's quicker. Instead of multiplying across everything in the numerator and then everything in the denominator and divide the two, I do it step by step. So here, I get 16, and I have 5 right next to it, and they're in the numerator, so I multiply those. And then I have this 3.1 to work with, so I'm going down. It's in the denominator, so I'm going to divide by 3.1. And then I have this 1,000 up here in the numerator. Okay, I'm going to multiply by that. And then I have this 1 down here in the denominator. I'm going to divide by that. So anything in the top gets multiplied, and anytime I switch to a number on the bottom, and is going to end up being division. Or you could just go this, and then divide by the 3.1 and divide by the 1, and that will give you your answer. So really, you can do things, differently. As long as you're following order of operations, you have to do multiplication and division together, all right, which is really what we're doing here. Okay, so let's put in our 16. We want to multiply that by our 5, and then we're going to multiply it by the 1,000. And then we're going to now divide, because we have this down here in the denominator, we're going to divide by 3.1. And then we really don't need to divide by 1 again because you're going to end up with the same number. So that gives us 25,806.5. So 25,806.5, and that would be meters. So that's how you would solve that problem. Okay? So there's an example of a two-step problem. This is a two-step problem. So now we're going to apply this math to something called a mole. But before we do that, we have to know what the heck a mole is. So a mole is a unit of measurement that we use in chemistry that basically makes things that are either way too large, it makes them smaller so it's a more manageable number to work with, or if it's something really tiny, it makes it to a larger number that's more manageable to work with. All right. So that's really the whole purpose of the mole, is it's a unit of measurement for mass that makes it either larger or smaller so it's easier to work with and do the math around it. Unit of measurement for mass that makes the number more manageable to work with. And that's in general what it does. That's not really a good definition. If you were to actually look it up online, it's not going to be that. They're probably going to tell you things like this. They're going to tell you that 1 mole is equal to so many atoms, ions, or molecules. In fact, 1 mole is equal to 6.02 times 10 to the 23rd atoms, or if you're talking about another particle like an ion, or if you're talking about another particle called a molecule. So it's used to take something that's extremely large and convert it into a number that's more manageable to work with, because numbers in scientific notation are more complex to work with. And remember, if this is a positive 23, which it is, that means move this decimal 23 places over to the right. So it's a really big number we're working with. All right. And these guys down below here, they have a name as well. They're called the representative particles. So again, this isn't really a good definition that you would find online, but I'm just trying to make it so you understand the reason why we're using the mole. It's the goal is to use numbers that are easy for us to comprehend instead of something really large and really small. And so in this case, we're taking this very large number and we're converting it into something that's more manageable, where you're working with just like, a number like 1 or 2 or 3. So that's one definition. So there's really a couple definitions that we can have for the mole. Another one that you can have is that 1 mole is equal to 22, well, we'll do the gram one first, is equal to, and I like to call it question grams, because that question mark can vary depending on what element you have. So for example, if we take a look at the periodic table, let's say we have the element, let's pick something with an easier number to work with. Let's say lithium. Okay, let's say we have lithium. Well, if you look at that number, it's 6.941. So when you're talking about lithium, that question mark gets replaced with 6.941, right? So let's maybe write that down. So 1 mole would equal to 6.941 for lithium, and that's grams. Well, what would it be if it's like maybe one of these guys over here? Either nitrogen, oxygen, or fluorine, or chlorine, or bromine, or iodine, or hydrogen. Do you remember what's significant about those guys? Is that they all have a line going through them, okay? So that means that in real life, since they're diatomic, they come in pairs. So if we wanted to do, for example, oxygen is 15.9994, but you have to realize that 1 mole of oxygen is not going to be 15.9994 because oxygen is diatomic. Instead, it's going to be twice the amount. It's going to be like 32.0 something, something, something. Okay, so it's going to end up being double. You have to multiply it by 2. Now the video is tricky because they give you an example similar to this where I think they give you moles and have you convert it into grams of oxygen, but they actually act as if it's not O2. They for some reason didn't include that it's diatomic. They just use the 15.9994. So when you go to do that for a practice problem, if you use 32 in there when you go to do your calculation, you'll probably end up with the wrong answer. Really, you're right because it should be an O2, but for some reason the Apex curriculum is showing that oxygen is a monatomic and it's really a diatomic. But anyways, okay, so that's how you do that. So really it depends on the periodic table. So the question mark means the periodic table. Look on there to get what that number would be for your question mark. Okay. Another one that we have is that 1 mole is equal to 22.4 liters if you happen to have a gas. It only works for gas. Well, oxygen is an example of a gas, and helium is an example of a gas. So really, it's for gases only. And really, gases only that are what we call STP, at room temperature and pressure. But that's another lesson in the future about gas laws, all right? So just know that you can use this liter thing if you happen to be working with a gas like helium or oxygen or hydrogen, carbon dioxide, things that you know are gases, and you could use this to help you solve it if you're given a volume and you have to convert it into moles, or the other way around. And another one is, I call it X mole, Y mole. And what that has to deal with, it's not a very good looking Y, what that has to deal with is a balanced equation. So let's maybe throw in a balanced equation up here. If we take hydrogen and react it with oxygen and we combust it, we'll make water. So if we balance that, because we only have 2 here and a 1O here, we have to double this one. But in the process, we double the hydrogen, so now we have 4. So we needed 2 here. So let's say we were going to convert maybe from X mole would be maybe hydrogen, and then Y mole would be oxygen. Well, you would use these coefficients that are in the front. There's nothing written here, so you assume that number is a 1. So basically this says 2 moles of hydrogen is equal to 1 mole of oxygen. So really, there are a whole bunch of definitions for the mole. But it's basically a base unit that in chemistry we try to convert everything back into. And then once we get into the mole, we convert it into something else. All right. Okay. So let's deal with some problems that have to deal with dimensional analysis using the mole. So let's start with a real simple one. And I'm going to actually just kind of move this up here so we have these. Let's say that we have, let's say, 8 moles of hydrogen, H2. And we want to convert that into maybe how many, now what is hydrogen? It's H2 an atom, an ion, or a molecule. Well, because there's 2 of them and they're bonded together, they are a molecule. So we're going to start with 8 moles of hydrogen. Let's turn that into molecules. So we're going to go ahead and use our dimensional analysis. We'll start a little grid thing. Remember, what's given always goes up top. So they give us 8 moles of hydrogen. And what goes on the bottom? Remember, you want to cancel out those units. So they come down here, moles of hydrogen, both of them. And it's really important as you do this stuff, you label not only the substance, but what amount it's measured in. So there should be really 2 things here you're going to cancel out whenever you do this. Okay? Now we need a conversion factor. Well, do we have one for moles going to molecules? We sure do. It's right here. 1 mole is this number, atoms, ions, or molecules. And this number here, by the way, is called Avogadro's number. And he was an Italian scientist that came up with that number. He mathematically calculated it. And I used to always remember it as avocado. Avogadro sounds like avocado, so Avogadro's number. All right. So let's use Avogadro's number. Well, he says that 1 mole, well, next to our mole, we're going to put our 1, is equal to 6.02 times 10 to the 23rd. And that's molecules. So we can go directly to that step because we have a conversion factor that goes from moles directly to molecules. 6.02 times 10 to the 23rd molecules of H2. And you got to be real careful. Some people think, oh, mole, that must be short for molecule. No, it is not. It's a different thing. So be careful with that. Now, I'm going to go ahead and do calculation for that, but I need to turn my calculator sideways so I can get the scientific notation numbers. So type in our 8. We're going to multiply that by our Avogadro's number, 6.02. And you see this little EE button right here? That's exponential notation. That's scientific notation. We're going to go ahead and push that. And when you do that, you don't have to put the times 10. You don't have to put that base 10. You just type in the power. So we're going to type in 2, 3. And then hit the equal sign. And that's what that number is. That number is 4.816. Now the E means times 10 again. Remember how we hit like the EE down here in the calculator? So this means times 10 is to the 24th power. right? And that's going to be molecules because we didn't cross out those units of hydrogen. So that's how you would do a one-step problem. Okay. All right, dealing with the mole. So let's try another one. Let's maybe use one of these other things in here. Maybe go the other way. Let's maybe look and convert it into moles. So let's start with maybe we'll use this one. We'll use the periodic table for this. So let's say we're dealing with the substance sodium chloride, very simple substance, sodium chloride, NaCl. And let's say that they start us off with 3 moles of NaCl. And in this problem, we want to convert that into question grams of NaCl. So how would we do that? Let's set up our little grid. What's given goes in the upper left-hand corner, 3 moles of NaCl. We want to get rid of moles of NaCl, so bring them down. And now you're like, okay, I need a conversion factor, something over mole. Do I have anything that helps me go to gram? Well, yeah, I do right here. I can go directly to mole. 1 mole equals question gram. So in front of my mole here, I'm going to put that 1, just like it is up here. There's a 1 in front of that mole. And then the other side of the conversion factor, the question gram, is going to go up top. Remember what that question mark means? It means to look at the periodic table, the PT. And that's for NaCl. So we're going to go ahead and do that. We're going to look on our periodic table for Na. And if we look at Na, it's 22.989770. And if we look at chlorine, it's 35.4527. So we're going to add both of those numbers together because we're doing it for the compound NaCl. And there's 1 Na and there's 1 Cl. All right, so we're going to add those guys up. So let's do that. My calculator, my phone going again. So, maybe that was scientific notation. Clear that. And we're going to type in, wrong one, sodium, 22.98977. And we're going to add that to 1 chlorine, because that's what the formula dictates, 35.4527, and we get 58.44247. Now, we really don't need to go that far out. You could use something called significant digits, but, just to make it easy, let's just round all our numbers to 3 places. So 58.442. 58.442. All right. So we're going to now take that number and we're going to multiply it by 3 because they're both in the numerator. And so we get 175.327. And that would be grams of NaCl. So that would be our answer. All right, so this is our answer for this one, and this is our answer for that one. Okay. And so again, be careful of that, because let's say you were working with this, like H2O2, hydrogen peroxide. What you would want to do if you were figuring out what this number is to go into this type of problem, you would go ahead and look on here and realize I'm going to have to double that because my formula dictates that. It says I got 2 of them, but I'm going to have to double the oxygens. So 15.994 can get multiplied by 2 as well, and then you add them up, okay? And that would give you, and what this is called, by the way, this is referred to as molar mass when you have it written as grams per 1 mole. So when you're doing this second step right here, there's a name for that. We call that molar mass. You're figuring out a molar mass for a substance. How many grams are in 1 mole? That's another definition that Apex Unit 4 gives you in that first section. All right. I think I want to do one more problem with you guys, and that's showing you maybe go the other way, and then I'm going to stop after that. So let's scroll this up, get some of these papers out of here. I still want you to be able to see those 4 conversion factors because we're going to use them, and let's maybe try and do another problem down here. All right, so let's say that in this next problem, they start you with 15 grams of sodium chloride, NaCl. They want you to figure out how many moles that is. Right? So how would you do that for NaCl? Well, start off the same exact way. You put what you're given up here, 15 grams of NaCl. You want to get rid of grams of NaCl, so repeat them down here. And then you need a conversion factor that allows you to go from grams to mole. Do you have one? You sure do. Molar mass allows you to do that. Question gram equals 1 mole. Question gram, so we already added that up in the previous problem. It's 58.442. And then here it tells us 1 mole is on the other side of the conversion factor. So on the other side of the conversion factor is 1 mole of NaCl. And then you would just go ahead and divide the two numbers to solve. So we would need 15. So we would take 15 divided by 58.442, and that would give us 0.086. 0.086, and then the units are mole of NaCl. That would end up being our answer, 0.086 moles of NaCl. Now, I want you to notice something. The reason why I wanted to do this problem is that notice what happens when you start with moles. You bring moles down and grams is up top. But if you start with grams, you bring grams down and moles is up top. So you don't always have 1 mole down in the denominator like we did in the other problem. Sometimes that 1 mole can appear up in the numerator as well. And what dictates that is what is here, because it has to cancel with down here in that denominator, right? So that's all I'm going to cover for tonight, and I hope that gives you a good start with Unit 4. When it starts talking about the mole and it starts talking about dimensional analysis, you'll have an idea. You know now that there's 4 different definitions for the mole. And the whole idea with the mole is to just try and make things scale down to a number that's more manageable and easier to work with, instead of working with these really screwed up numbers that are really big and these ones that are really small. Okay? So have a good evening, everybody. Take care. Bye.